Imagine a client says, I want a new online banking system. Before you open a code editor, they will ask 4 questions. How much will it cost? How many developers do you need? How long will it take? And when is the exact deadline? You cannot simply guess the answers. If you estimate 20 lakh and it costs 50, your company absorbs a massive financial loss. If you guess 80 lakh and it only requires 40, the client takes one look at your proposal and rejects it for being too expensive. Before building a house, the owner calculates exact material and labor expenses, pricing out bricks, cement, and builders. Software requires that exact same accounting for digital materials. Instead of bricks, you pay for developer salaries, software licenses, cloud infrastructure, and rigorous testing. A software cost estimate requires predicting the expense of that entire digital ecosystem long before development begins. This flowchart maps out the actual components of total software cost. The baseline calculation must include salaries for project managers, QA testers, UI designers, and ongoing maintenance fees, alongside the programmers writing the code. Grouping these expenses allows software companies to do 3 crucial things: prepare an accurate internal budget, determine if the project is economically feasible for the client, and accurately forecast the final profit margin. However, these baseline expenses are highly volatile. They are driven by several core factors, and the absolute largest multiplier is the sheer size of the software. A larger application requires more code, which demands more effort, immediately driving up the cost. Here is a direct comparison showing a simple standalone calculator app on the left and a dense enterprise architecture on the right. Building the calculator requires minimal effort, but an enterprise banking system requires broad detection algorithms, strict security protocols, and real-time transaction processing. That added complexity requires specialized testing, premium cloud platforms, and highly experienced developers. Missing even one of these amplifying factors during your initial planning guarantees a budget overrun. Because these elements are interconnected, altering one project variable forces a cascading effect across the entire development plan. This linear progression illustrates the exact sequence. An increase in software size dictates the necessary human effort. That required effort dictates the development time, which ultimately determines the final cost. If you substitute a large team of novices with a small, highly experienced team, your hourly salary rate increases. That drives the total cost up, even if the overall development time decreases. So, if you are planning a massive, high-security banking platform requiring strict data encryption, which specific factors will drive your price the highest? Think about the sequence. The checklist isolates the 3 primary culprits: the high complexity of encryption, the specialized technology and hardware required to run it safely, and the massive team size needed to build it within a strict deadline. Trying to manually track how an expanding team size affects development time and cloud hosting costs is mathematically overwhelming. The software industry requires formalized calculation frameworks to manage this data. This tree diagram breaks down software cost estimation models into non-algorithmic and algorithmic branches. Non-algorithmic techniques, expert judgment, analogy, and Delphi rely on professionals comparing new projects to past ones. Algorithmic models use objective formulas. Kokomo and Putnam run variables through equations to calculate exact effort. As you begin applying these models, use the acronym COST to remember your objectives. C. Calculate the project budget. O. Organize your resources. S. Map schedule and software size. And T. Estimate total project expense. Understanding how project size, complexity, and team experience interact is the required foundation. Now that you have mapped the variables, you can apply them to the mathematical formulas of the Kokomo algorithmic model in the next phase.